solving compound inequalities. Sometimes inequalities are described using two inequalities instead of just one. When this happens, a compound inequality is written to represent the situation. And we have two different kinds of compound inequalities. One is with the word and the other is or. And the and one is where the two parts cross each other, basically, and that's called a conjunction. So in conjunction is the word and. So if you have a statement like x is greater than or equal to -3 and x is less than or equal to 5, that's a conjunction. And it's a conjunction because the word and connects the two inequalities. So here's a graph of the two of those. On the top here, you have x is greater than or equal to -3, and so we put a dot at -3 and anything greater than that. And then you have x is less than or equal to 5, and you can see then we put a dot at 5 and it's equal to, so filled in, and anything less than that is going left. And so where the two of those cross each other in that center section, including the endpoints, is what we get when we draw a conjunction. So here's the endpoints and everything in between that those two have in common. So when we have an and, we take the combination of where those two things are crossing. And so any number that satisfies both inequalities is a solution. And both inequalities being satisfied is only the set of solutions that are between the points -3 and +5. So a conjunction can be solved as two inequalities connected with an and, or as an inequality with three parts. So here's how you would write this if it was an inequality with three parts. It's 8 is greater than or equal to x, which is greater than or equal to 3. We could do that with this equation up here, and we would start with the low point, which is -3, and -3 is less than or equal to x, which is in turn less than or equal to the top number, which is 5. So there's our 3 and our 5, and you can see here is the part, and here is the other part. So there's two parts to that, and they're basically crossing them. So, cellular phone contract includes a monthly usage fee of $10 plus an additional 10 cents per minute of talk time. Suppose the monthly cell phone bill is between $30 and $40. Write a compound inequality that describes the situation, and then solve the inequality to find the number of minutes that can be used to keep the monthly bill within the desired amounts. So, first thing we want to do is write our equation with its two parts, or we could write it as one. So there's two methods here, and I'm going to go over both of them. So we know that this money amount with the $10 plus 10 cents a minute needs to be greater than $30. So that's the first equation. And then the second equation is where it's less than or equal to $40. And so we could solve those two equations and find the two answers to this and then graph them. So let's do that. We would minus 10 from both sides. And so we would have 20 is less than or equal to 0.10x. And then last step, divide by 0.10. And when we do that, we get 200 is less than or equal to x. On the second equation, we would do the same thing. We would minus 10. And so we would get 0.10x is less than or equal to 30. And then we would divide both sides by 0.10. And so we would get x is less than or equal to 300. And so we have these two inequalities now where we have 200 is less than or equal to x, and x is less than or equal to 300. And so really what we have is 200 is less than or equal to x, which is less than or equal to 300. We can combine that into one statement. Here's the way to do this if you are going to do it with the 3 parts. And this is a little bit different than what we've done before. But it's not really, because when you subtract 10, you have to subtract 10 from all parts of the inequality. So just like you'd subtract it from both sides of the equal sign, you're going to subtract it on all parts here. And so we're going to subtract it on all 3 parts. And so 30 minus 10 is 20, is less than or equal to 0.10x, which is less than or equal to 30. And then we're going to do the same thing when we divide. When we divide by 0.10, we're going to divide all of the parts by 0.10. And so we have 200 is less than or equal to x, which is less than or equal to 300. So this process, the second method, solving this conjunction, uses just basically one equation and does it whatever you're doing to all parts of that equation. And the whole objective here is to get x alone in the middle. So before this, we've always had to get x on one side of the equation or the other to get it by itself. And here we want to get the x in the middle and everything else away from the x so we can figure out what the 2 numbers are. A disjunction is a compound inequality that uses the word or. And if you think about conjunction and disjunction, conjunction means combine, and disjunction means dis, or away. So when we talk about disjunctions, we're talking about 2 separate inequalities that are going different directions. So they would look like this. One is going one way and one is going the other. When we talk about and conjunction, we're talking about them going towards each other and where they're crossing, or where they're meeting up, actually. So we're talking about the in-between. And when we talk about disjunction, we're talking about away from. So this first problem says, write and graph a compound inequality to represent the statement. So all real numbers that are greater than 9 or less than 3. So where x is greater than 9 or x is less than 3. And so we want to combine that. So let's put the x in the middle. And so we're going to flip this first one, because 3 is less than 9. We're going to put the 3 first. And we're going to 3 is greater than x. And then x is greater than 9. So 3 is greater than x, but x is greater than 9. So let's graph that then. So let's put my 0 over here. So here's our 3, and it says x is less than 3. So we have an open circle on 3, and we have going less than. And then we have where x is greater than 9. Open circle again, and going to the right. So you can see that those are not joined. They are actually disjoined, so going the opposite directions. So here's another one. It says all real numbers no more than 7 and no less than 11. So no more than 7 means that x has to be less than or equal to 7. And no less than 11 means that x has to be greater than or equal to 11. And so if we graph that again, then we're talking about numbers that are less than or equal to 7. Fill in the circle, going to the left. Fill in the circle on 11 because it's equal to as well, and going to the right. So there are the numbers that are no more than 7 and no less than 11. When we're solving disjunctions, we solve them just like we would on any other equality or inequality. So on this, we're going to solve the 2 parts. So here, x minus 3 is less than negative 5. So we're going to add 3 to both sides. And so x is less than negative 2. Or, we're going to solve the second one. We're going to divide both sides by -2. X is less than 3. So x is less than -2, or x is, we forgot to do something when we divided here. Remember, when you divide by a negative, that you should change the inequality. So please be careful of that, that you're changing the inequality there. Okay, so let's graph that. Here's 0, here's -2, and 3, and all numbers that are less than -2, not including -2, are those numbers. All numbers that are greater than 3, but not including 3, so again, open circle, are those numbers. All right, math reasoning question. It says, justify why is all real numbers the solution of the disjunction x is greater than -2, or x is less than 3. So let's take a look at what that graph looks like. And so here's our 0, here's our -2, here's our 3. And so when we have x is greater than -2, so here's -2, and it's greater than, and x is less than 3, and that goes this way, then which numbers does that cover? Well, that covers all numbers. So the solution to that is all real numbers, because it covers all numbers on the number line. -2 is not covered by x is greater than -2, but it is covered by numbers that are less than 3. And same thing with 3. It is not covered by x is less than 3, but it is covered by all numbers greater than -2. So we can have all real solutions for answer, or all real numbers for a solution for an answer when you're writing disjunctions. These last two, they would like you to write a compound inequality that describes each graph. So I'm going to write these separately first and then combine them. So we're talking about this one right here. That is a -1. And we're talking about numbers that are greater than -1. So x has to be greater than -1. And it's not equal to because it's not filled in. On the other side, we have 5. And we have all numbers that are less than or equal to 5 because it's filled in. And so really what we have is -1 is less than x, which is less than or equal to 5. All I did is I took this thing and I flipped it around and wrote it down there. Okay, so -1 is less than x, which is less than or equal to 5. Same thing on the next one. Only this one is an or. So we can, we should really put the and in here. You could have this answer on the top, or you could have the joined one on the bottom. On this one, we can only have the or. We have x is less than or equal to -2, or x is greater than or equal to 4. So we have the two parts there separated by an or. On the first one, it's a conjunction, so it's an and you have the two parts, or you combine them. And on B, you have the or.